We're going to determine an angle involved in a special triangle. So here, the cosine of theta is equal to negative root 3 over 2. And we're going to find all values of theta that will make that work between 0 and 720 degrees. Now, if you know what cosine looks like as a curve, that's 360 and that's 720. What we're looking for is all the values of theta where cosine is equal to negative root 3 over 2. So somewhere down here at negative root 3 over 2, there are 1, 2, 3, 4 values of theta that give us that cosine value. And we're going to find all of those values using a special triangle. Now, if you can't remember your special triangles, I'm going to show you a trick to help you. For the first special triangle, draw a square. Now, if you're learning this, I'm assuming you know that all the angles inside of that square are 90 degrees. Let's give that square a side length of 1. And now draw a diagonal across. So this is 90 degrees, that's a diagonal. That diagonal is going to bisect this angle, so it's 45 here and here. And through the Pythagorean theorem, you know that the hypotenuse is the square root of the sum of the squares of the other two sides. So that's 1 squared plus 1 squared. So I can redraw that triangle here, where that's 1, 1, 90, 45, and root 2. That tells me that the sine and the cosine of 45 degrees is 1 over root 2. And the tan of 45 degrees is 1. Our other special triangle, to remember it, start with an equilateral triangle. You draw an equilateral triangle, every side is the same and every angle is the same. Now, you know all the angles have to add up to 360 degrees. Sorry, my apologies. You know all these angles have to add up to 180 degrees. So for them to all be the same, they all have to be 60 degrees. Okay, now we're going to bisect that angle. And by the symmetry of our equilateral triangle, you can see that it's going to land here at a right angle at the halfway point. All these side lengths are the same. Let's call this, because it's the shortest length here, let's call that 1 unit. If that's 1, and that's the halfway point of our equilateral triangle, then that has to be 2. And because all the sides are the same, that's also 2. Now 2 is our hypotenuse. That means that this squared plus that squared is equal to 2. So let's say we don't know what that is. That squared plus this squared is equal to 2 squared. 2 squared is 4. So whatever's in here, when you square it, it's equal to 3. So that's got to be root 3. So that gives us this special triangle here. Oh, and by the way, that was 60 degrees and we cut it in half. So in here, that's 30. So we've got this triangle where that's 30. This is a right angle. That's 1. That's 60, because this corner is this corner. That's 2. And that's root 3. So if you ever forget your special triangles, draw a square, draw an equilateral triangle, cut them with lines, and then reason it out. Okay, so back to the question. So we're to find all values of theta between 0 and 720 degrees where the cosine of theta is negative root 3 over 2. So we're going to start off with a special triangle that's got root 3 and 2. So I've rotated it from the version I had before, but this is our special triangle where 1 is opposite 30, 60 is opposite root 3, and the hypotenuse is 2. The cosine of 30 is the adjacent over the hypotenuse. So the cosine of 30 degrees is equal to root 3 over 2. So this gives us a clue as to how we go about doing this. Now notice the cosine of theta is not root 3 over 2, but negative root 3 over 2. To deal with such a case, we've got to expand our definition of trig ratios, so we're not just inside of a triangle, we're looking at ratios around our coordinate grid, where the cosine of the angle is equal to the y value over the r value. So if this is our angle here, we get a triangle in here with this y value and that r value. R is a radial arm, and it's this always positive distance from the origin as we rotate around. Y is our height, and x is how far over we are. For the cosine of theta to have a value of negative root 3 over 2, we have to be over here. We have to have some negative x value. Oh, correction. Look at this. The cosine of theta is not the y value. It's the x value over the r value. The sine of theta is the y value over the r value. Okay, so the cosine of theta is negative root 3 over 2. That means we've got to go over here, root 3, and we'll have a radial arm a distance of 2. So that's our negative root 3 in here, and that's 2. So we could be up here, or we could also be down here. So our angle could be this angle here, I'll call that theta 1, where we've got this special triangle where this is 2 and this is root 3, which would make this 1 and this 30. Or we could be down here where that's 30, that's 1, and again in here is root 3. So that's theta 1. That's theta 2. And these are two values between 0 and 360 degrees. To find the other values, we'll go all the way around and then come back to that. I'll draw them out on a separate diagram as not to overlap things too much. So what are these values? For theta 1, let me just redraw that. We have an angle of 30 degrees here, which allows our special triangle to be root 3 over 2, negative root 3 over 2. And a rotation from here all the way down to here would be 180 degrees. And we're stopping 30 degrees short of that. So theta 1 is 180 minus 30, making it 150 degrees. Theta 2, our second angle for which this works, we'll finish down here with 30 degrees there, which gives us our special triangle in here with that as negative root 3 over 2. And it's 180 degrees plus 30 degrees, making theta 2 210 degrees. So given this, we can now say theta is equal to 150 degrees or 210 degrees. And remember, we're going to look for two more answers as we go between 0 and 360. Our next possible solution, if that's 30, is we can go 360 degrees plus yet another 150. So our third angle is 360 plus 150, which makes it 510 degrees. And then finally, we can arrive here after doing a full rotation. So remember, that was 30 degrees because that gives us a special triangle where this is negative root 3 and this is 2. A full rotation is 360, plus we're going to add another 210 degrees to bring us there. So our fourth allowable angle is 360 plus 210.
Sorry for the interruption. Could we have all
570 degrees.
join us in the Learning Commons at 11 for a very, very brief meeting? That's all staff. Please join us in the Learning Commons at 11 a.m. for a very brief meeting. Thank you.
So if the cosine of theta is negative root 3 over 2, theta could be 150 degrees, which is here, or 210, or 510, or 570. And all of those solutions allow that arm to form a special triangle where the x side has a value of negative root 3 and the radial arm has a value of 2, giving us the required cosine of negative root 3 over 2.